We envision the next kind of Facebook on chain, the next social network on chain will be on Move. Move is really designed to be the most secure and fastest VM. I think the biggest concern that, when I talk to my parents or anyone who's involved looking at getting crypto, they're always like, oh, is it going to get hacked? Isn't it a scam? In this world where you have thousands of rollups, the biggest question is how do you create a seamless user experience?
Welcome to the Bare Metal Podcast.
Hey everybody, welcome to the Bare Metal Podcast. Thanks for tuning back in. This is your trusty Ship the Code. Today here with Rushi of Movememnt Labs. Welcome.
Hey, thanks for having me, guys.
Excited to have you on. So, can you give us a little bit intro to yourself and, how you came to work on Movememnt Labs?
Yeah, Rushi co-founded Movememnt Labs. My background is engineering. Started my career at United Health Group, was lead engineer in space, converting on-prem databases to the cloud. Then got into crypto, I'd say 2.5 years ago, predominantly engineering the space. Went to Aptos ecosystem August of 2022, contributed to one of the first DEXs in the ecosystem. My co-founder, Cooper, built the first yield aggregator in Aptos. It's called Sate. So we have two of the earliest Move builders in space. Pretty early on, realized that the Move language is very exciting. For me, I just found an article one day that Facebook was building a new programming language. I started delving into it and really understand the thesis why. Facebook, the biggest consumer app in the world, wanted to power stablecoin for their app, but couldn't do so because of limitations of the EVM in terms of security and scalability. So they built a new programming language in VM to actually have users on chain. When it came to Apps Suite, we really loved the technology, but wanted to bring it to Ethereum in a Web3 native way. So that started Movement Vision, the first move layer to an Ethereum. Really part of the modular stack and bringing next-gen VMs to ecosystem liquidity. And super excited to be on the podcast today to share more about what we're building and kind of the vision behind Movement.
Pretty cool. Sounds like Move language is really a centerpiece. I guess it's also the Move in the Movement Labs sort of part. So, tell us more about Move, right? All I know is it's sort of like a built off of the Rust language, but there's obviously a lot more to it since you guys are so excited.
Yeah, so it came, again, going back to the DM project, Facebook wanted to build a framework that could support billions of users on the app itself. The EVM itself at the time and still today is very unproven. Yeah, you have 10,000 users on chain, but you look at inscriptions, it's kind of a use case of when things go wrong. Most EVM chains went down. Those that didn't go down were at $500 gas fees, which made it pretty much unusable. Move is really designed to be the most secure and fastest VM. So the analogy I could say is Move is to Rust as React is to JavaScript. So it's a Rust-based framework. Similar to Anchor is a framework on top of Rust. Move and the language itself and the VM itself is also a framework that you can kind of visualize. It's a spin-off of Rust where you have certain libraries and modules that make it really easy to program. So the first thing is on speed. You have Block STM, which is a parallelization engine, which I'm sure we'll touch on later, that's built into the VM itself. So you can do high throughput applications, multi-threaded processing. So the thing about parallelization is kind of when you have single-threaded environments, it's very toxic for kind of managing state flow as well as managing state congestion. So for example, when you have inscriptions or some game going crazy on one thread, in a single-threaded machine, that means the gas fees go insanely high through the roof. So if you have inscriptions on an EVM chain and use Uniswap on the same chain, the gas fees for Uniswap would be much higher, even though the user is not using the game. With parallelization and Block STM specifically, which is kind of the godfather of parallelization, you have multiple different threads. So if you have a game going crazy on one thread and having a lot of users and traffic, it doesn't affect Uniswap on another thread. It doesn't affect DYDX on another thread. You actually have multi-thread execution, which enables you to have multiple apps. So instead of needing L3s, L4s, L5s, you can just need multiple threads between L2s, so it actually stops the layer 2 itself. Going back to the Move language, like I touched on, you have parallelization, which is Block STM proving ecosystem in terms of parallelization. And the last bit is on security. So this is kind of where it differentiates from the Solana VM, Fuel VM, and other parallelized VMs. Move actually has formal verification built into the VM, which is through the thing called the Move Prover. Essentially, I don't want to get too technical, but when you submit smart contracts to the VM, it checks a resource type memory safety through a series of solvers. So say, for example, you have re-entry attack or you have integer overflow, it's actually disabled by the VM and can be caught at runtime. So that actually enables you to stop a lot of the attack vectors we're seeing today in crypto.
Can we dive into that part a little bit more? So formal verification, I think, is it's a tough area of computer science. I'm excited to see
Yep.
it's somehow touching production. So can you talk about which part of the Move VM is formally verified? Are we talking about Ethereum opcodes or some invariants around smart contracts? What is the stuff that is actually captured in the formal model? And then, how is that checked against, the runtime operation?
So the language itself isn't formally verified. We're actually working on formally verifying language. It's the prover itself that conducts formal verification checks. So within the VM itself, you have bytecode interpreters and bytecode compilers that check for resource type memory safety. So the proving and the formal verification models come from the move prover itself, which is in the VM. The language itself is not formally verified. It's actually something that we're working on with different groups. But the formal verification comes from a series of Z3 solvers. So when you execute a smart contract, let's say Move, for example, it goes to an algorithm and says, hey, is there integer overflow of this line? Is there a real stack vector? And then generate, and then only execute code if the provers pass it. So you have bytecode compilers and interpreters that checks for essentially resource safety at the bytecode level.
And this is already built into the sort of Move, let's say, toolkit or language. I don't know how to imagine this. I know the Z3 are SMT solvers, satisfiability model theory solvers made by Microsoft ages back, used for device drivers. So definitely verified tech that's been around the block. And this is what's operating when the Move EVM is actually processing transactions. Those solvers are being executed.
Yes, so it works at runtime. It's at the VM level itself. So the move provers actually exist in the virtual machine. So every time you run a smart contract, it goes through the check process.
Wow, that's super interesting. I got to dig into that deeper. I had no idea. So we can dig deep, I guess, into Move. We've mentioned many interesting things like parallelization, but let's take a step back so we don't hawk the entire podcast just with Move. Although it's super cool. What are you guys building? What is the Movememnt network? I looked at the website, but it's got tons of docs. Can you give us sort of a 10K view?
So our mantra is move everywhere with Movememnt. When me and Cooper first started off, we fell in love with Move language. We believe that this is an impetus for bringing security and retail adoption onto chain. I think the biggest concern that when I talk to my parents or anyone who's involved looking at getting crypto, they're always like, oh, is it going to get hacked? Isn't it a scam? Isn't there a hack every week? And to be frank, they're right. If you look at Pack Shield, every week it's Richie attack, 3 million loss, 5 million loss, 6 million loss. We're so succumbed to attack vectors that it's pretty much normalized. But in reality, that's not how it scales. If you want retail on my mom or my dad or anyone to ever use crypto, it has to be securitized. So that's kind of the thesis behind why Move. And our thesis was we wanted to bring it to Ethereum through layer 2, which is M2, as well as we wanted other people and other systems to use it. So for example, Gaming, it's a Move VM on a BNB chain designed for gaming applications. We're now seeing a few more rollups as well. There are a few gaming DeFi applications that are on Ethereum, Celestia, even Avalanche now. Really coming to every ecosystem where we're able to extend our virtual machine, extend kind of toolkit that we built to build as different chains. So the kind of visualization model is you have M2, which is the optimism in this world, where it's a liquidity hub, the main rollup. You have the Move Stack, which is a VM and sequencer kit where anyone can launch a Move rollup, connect to the Move sequencer, which is M1, and launch a Move rollup and connect to the network. So the analogy M2 is optimism, Move Stack is the OP stack in this case, and the superchain is M1. So kind of creating an end-to-end ecosystem focused on the execution layer where anyone can launch their own custom Move environment and connect it to ecosystem liquidity.
So let's take it piece by piece. So M1 is sort of let's say the sequencer product that orders transactions, right? And then how does that work? Because do you guys have how do you already is this running? Do you guys have operators running M1 or what's the plan around this?
Yeah, so we have M1 as a shared sequencer. So we use a Snowman consensus for sequencing. So validators stake the Move token, participate in sequencing for the layer 2 as well as layer 1 or other layer 2s. If you look at the seller proposal, it's pretty similar where you have the seller layer 1. All the validators who stake the seller token are now sequencing the layer 2. So working to a similar model where we believe the centralized sequencers are broken today. They don't really scale. And also because our fees are 1 cent to 2 cents as a next gen parallelized VM, it's important that we have a decentralized sequencer for economic models, as well as able to keep up with uptime.
So I noticed you guys are using the Snowman consensus. Can you talk a little bit about why you guys picked this? Though that's the consensus developed for the Avalanche network, right, by the Labs team. Super interested to, excited to see this applied somewhere else. I thought Avalanche was going to be the only user. So what was your rationale?
I think when we first looked at it, we were like trying to bring the Move EVM to like systems. Post FTX, so it's like end of November. There's pretty much only 3 chains you could do it on. It was Snowman, Cosmos SDK, Tendermint, and then Substrate. And then really the reason why with Snowman was you had built-in compatibility with EVM because of Avalanche warm messaging, but most importantly, the low hardware requirements and also the ability to just have a native token bootstrap a validator. So if you're running a Snowman node, it's extremely low hardware requirements. You can run it on your computer. We actually inherit the validator set that already exists, so we don't have to bootstrap our own validator set. We can inherit the security of the existing Avalanche validators. They have instant finality, so as a next-gen chain, high throughput chain, it's very important for our sequencer set to have instant finality because it protects against reorgs as well as can keep up with the high throughput. And the last bit is that it can be fully permissionless. So we envision a layer 2 where the sequencer unit is fully permissionless. Anyone can join and leave the network at will, and you can participate in sequencing. So first, fully decentralized and democratic layer 2. It's pretty much only possible with Snowman given that Tendermint caps out at 150 validators. We envision a world where we'll have more validators than that. Potentially thousands, and Snowman is pretty much the only place to do that.
Super recommended to anybody who wants to nerd out on consensus to go read the Snowman and even the original. I think Snowball was the original version of the protocol. It's using basically bit flipping and making decisions between binary choices in sequence to build consensus on what the chain is. Super cool. So let's go to M2. This is where I guess the heavy lifting is done with the fast transaction processing and parallelization. Be super happy to delve into that here. So M2 uses the Move VM. You guys have implemented an EVM in the Move language. Is that right?
Yes. So we call it the parallelized MEVM. So you have the Move VM, which is derived from the DM style virtual machine. And you have the EVM interpreter built on top of the virtual machine. So it works like Solana and Solana, but much more baked into the VM.
Mm-hmm. And so what are the main, we mentioned sort of security and sort of running, SMT provers during execution is super cool. And you mentioned block STM several times. So STM, I'm guessing, is software transactional memory.
Yep.
So can you explain like how STM works? Why do you guys pick this approach, to implement parallelization?
So it came out of the box with the DM virtual machine. If you look at the early DM projects, the early Aptos papers, the benchmarks of block STM were like ridiculous. Even like Monad right now is actually built up the DM BFT consensus in the parallelization engine designed by the Facebook DM team. So most, if not all, recent parallelization efforts have been some kind of derivative of the DM block STM pattern. We had the benefit of inheriting that, so we aren't focused on like optimizing the parallelization. It's already pretty high performant. I think the latest tests in theory were 145 TPS, and recent tests are like not like 20,000, 30,000. So from a TPS point of view, block STM is pretty much perfect. There's not much need to iterate upon it. So we got to inherit all the work, and since we have a direct DM style virtual machine built in, we have parallelization built in for all the Move smart contracts as well as any EVM smart contracts that are running on the network. So if you're running a EVM code, it'll essentially interpret down to bytecode, and you'll still have the engine. So we can essentially bootstrap EVM parallelization.
So one of the interesting aspects of, I'm guessing, the block STM construction is that when I'm interacting, I guess this is more of a developer point, but when you're developing with Solana, because of the way the C-level VM is parallelized, you have to tell it ahead of time what data you're going to touch. So the scheduler can schedule parallel transactions that don't touch the same, they don't write to the same state. Like the entire point, if I understand correctly, of block STM is that you don't have to do that it optimistically just goes ahead and executes. And if there is a rollback, it'll just handle this internally. So now that reduces the load on the developer because chewing nails chewing glass is a real thing with Solana devs, but you guys are getting around that, right?
Yep. So optimistic parallelization is kind of the one main design choices of block SDM. It allows you to, like you touched on, you don't need to specify the different contact points for a different transaction. It's kind of baked into the VM itself. So if you're looking to build an order book, I think it's the best example because building an order book on like a crankless order book on Solana is pretty difficult. And I think there's like one team pulled it off. But there's a lot of like transaction clashing that you make sure you're calling something with. Because you have optimistic parallelization with a DM-rich machine, you don't need to worry about that.
What else are you guys doing around security on the MoveEVM or around protecting users? Like, do you have any novel approaches around sort of preventing fraud or somehow handling fraud?
Yeah, so there's two main angles. We'll have more content around this, but on the VM side, the Move side is pretty bulletproof. Like we've inherited a lot of work from AppDOS and the DM project. We're really focused on the EVM side because, for context, the Move side at the moment is dynamic dispatch, which means that registry is not possible. On the EVM side, dynamic dispatch is still enabled because you don't want to create conflicting states. So one thing we're working on right now is adding compiler flags and trying to enable disable registry even though you have dynamic dispatch. You look at Arbitrum's EVM++, they did something similar where they have compiler flags and they're able to actually provide flexibility to developers to disable registry. Registry is actually like a feature, not a bug, but in cases that it's exploited, it is a bug. So for certain use cases, you want developers to be able to shut off registry. So we're putting a lot of compiler flags and trying to optimize the EVM side of things. So on the VM level, our engineering focus on form verification is how can we make the EVM side of things as secure as possible. Move will always be the most secure way to write code. It's the easiest language to write secure code. But if you are writing legacy code, how can we optimize that? The second thing is we're really focused on sequencer security. I think everyone today is focused on parallelization and kind of speed. But the thesis is it's a Lamborghini without brakes. Just because you have 20,000 TPS doesn't mean it's a good thing. If you have 20,000 TPS for a hacker attack, that means your funds can get stolen instantly. So how do you have high throughput while having breaks in the system? So that's what we're looking at monitoring at a sequencer level. So how can you have a sequencer that can be decentralized as well as monitor mempool for like any transactions that come in? For example, let's say, there's an integer overflow, a bad opcode that's pushed to the mempool. Is there an ability for a sequencer to monitor that and potentially move it to the back of the list and then chop it off? So that's something we're spending a lot of research on. And the last bit is on insurance. I think one thing that's been under the radar is insurance in today's crypto economy is pretty poor. If I want to deploy capital on chain and get collateral back the rates are pretty much like through the roof. Funding rates don't really make sense in terms of insurance. So it's really hard to get predictable models. In a world where smart contracts are not secure, you can now have insurance rates that make sense because it's actually easy to kind of adjust and risk adjust the different smart contracts for different vaults. So if I'm a family office or liquid fund deploying ETH into a vault, I can now potentially get insurance to back my investment because now I'm on a fully formally verified vault and strategy. So yeah, 3 levels of insurance. I like to call it proof of security, where you have security at the VM level, you have security at the sequence level, and you have insurance as a fail-safe mechanism, which I'm happy to touch on more on.
Yeah, sounds super cool. Like I'm feeling that armor being built out around the Movememnt network. I guess I'm interested. I don't recall how Snowman and if Snowman actually does any slashing. Like, do you want to enforce some, some commitments from the sequencer operators that would require, them to be slashable?
Yeah, so you would require to be slashing. I think we modified the consensus with Snowman++ to add slashing mechanisms for the sequencer. So, for example, if a valid is misbehaving and not properly sequencing your transaction, they would be reprimanded and get slashed.
Is the slashing automatic? Is it a consensus operation, or is it some sort of? Are some breaks on that as well?
At the moment, I believe there's breaks, but as we go to mainnet, I believe we're working to get automatic. But I believe right now it's more manual on the DevNet side, as it's pretty experimental.
Right. I mean, one has to be careful on the other side as well, right? To avoid like incorrect slashing. I mean, EigenLayer has committees that can like veto slashing in specific cases in case of code bugs and stuff like that. So it's not like there isn't any procedure. It makes sense. You guys are obviously like pretty big on modularity. Are you excited by the idea? Are you looking at the future of the world where everything's going to be modular? What's your take?
I think like 2023 was the year of the DA. So you had Celestia, Avail, Eigenlayer really come to market and explain why mainnet Ethereum isn't the right place to sell Ethereum. As we're recording today's the day of the Denkin upgrade. So we'll see how poor Dang sharding kind of affects it. But most kind of results estimates don't expect it to actually have a big change. Full Dang sharding is a few years out. So the question is, in the next 2 or 3 years, how do you make rollups as cheap as possible? So that's when DA came to the market, is Celestia and the modular narrative, providing solutions for rollups to have alt DA. And then I just say 2024 is the year of the VM, where we saw obviously the Solana price action, the Solana craze really brought all the attention back to the SVM. People got to experience localized fee markets, got to experience the great user experience that parallelized VMs offer, and they kind of loved it. So that's how the whole parallelization craze happened. You have the parallelized EVM craze, you have like the SVM craze, Move EVM craze. And in the last like 4 months, we've seen a lot of maturity and adoption for the alt VM craze. And I think that's where the direction of the modularity, like modularity is more than this DA. It's all these different segments of the stack. So you have the VM level, which is you have alt VMs, formally verified VMs, parallelized VMs, ZK EVMs, all these different adjustments. You have sequencer level modifications. You have decentralized sequencers, base sequencers, shared sequencers. You have different DA layers. You have different kind of proof generations, and now you potentially have different settlement layers. So there's a world where Ethereum itself isn't the ultimate settlement layer. We've seen L2s in Solana, L2s in Bitcoin. So that's pretty exciting. Where we kind of fit in it, we're focused predominantly on execution layer. We believe in Move as a thesis. We believe in Move as a language and ecosystem, and really believe it can be extended everywhere. So we're complementary to all the rollup stacks. So imagine like Move on OP stack, Move on Arbitrum Orbit, Move on ZK stacks, and then whatever DA layer or sequencer that you want.
Shared sequencing, we haven't discussed this too much in depth. It's like one of the, I believe everybody's trying to create like shared sequencers which capture or are able to provide as much value as possible. And like, it feels to me like the highest possible value you could provide is like providing, atomic liquidity, like almost like the ideal state being, hey, I can call my smart contract on my rollup from that, borrow a flash loan on the other rollup, right? Do something and then return it in one transaction. Like, I guess that's pretty hard to get, but I'm curious, like, what do you think are the most important features for shared sequences, and what are you guys building in this space?
I think like you touched on, atomicity is the most important thing. Like in this world where you have thousands of rollups, the biggest question is how do you create a seamless user experience? So like Optimism is working on some superchain, ZK is working on kind of sequencer. And one thing that we're focused on is we want to be the leader in the next gen rollup network. So if you're looking to launch a parallelized rollup or looking to launch like a formally verified rollup, you can use the Movememnt stack, launch your Move rollup, and then connect to the base chain, which is M2 for liquidity. So just because you launch a new rollup, you shouldn't be siloed and make it difficult to bridge assets. You should have a larger network to connect it to make sure the transactions can flow smoothly. I think there's two answers to this. You do have the atomicity, but it's also being part of the overarching network. Like Superchain, you do have the composability, but the main value prop is like the base deal, right? Where you can join an overarching collective, be part of an ecosystem, be part of a movement, no pun intended, and then grow the ecosystem. So I think what we're seeing a lot is a lot of these next-gen rollups, whether from Aptos ecosystems, Solana ecosystem, they want their own custom app chain, but don't want to be like siloed. They want to be part of a broader network, a broader mission. So shared sequencing is both like a mantra as well as the technical benefits.
Right. I mean, everybody wants the control, but also the ecosystem to come with it, right?
Yep.
That makes sense. What sort of projects are you guys looking to attract to the Movememnt network? What do you think is going to be the killer app, to deploy on top? Like, is it going to be games because of the parallelization? Is it going to be DeFi because of the shared liquidity? What are you guys thinking?
I think in the short term is DeFi, and any ecosystem should prioritize DeFi. Like security is the biggest thing we're like aiming for in the short term, where every year there's $4.5 billion lost to smart contract hacks, 7.6 billion to date. So the question is, if any retail capital is coming on chain and coming to DeFi, it has to be fully verified and securitized. My thesis is Bank of America is never going to use the EVM. They're either going to use like a securitized VM like the Move EVM designed for Facebook, or completely build their own VM from scratch. So with that in mind, I think the main use cases that we're seeing right now is a lot of vault strategies, a lot of Lightning protocols that have got hacked in the past, that have got burnt, and now want to launch on a secure network. We're fully EVM compatible, so there's a much lower lift for rollups and DeFi apps that want next-gen features but don't want to rewrite the code base, as well as inheriting all the work that Apps and Suite have done in terms of growing the ecosystem. In a long-term playbook, I would say it's actually consumer, given the fact that Move was built by Facebook. It was designed to be the consumer language and framework. So we envision the next kind of Facebook on chain, the next social network on chain will be on Move. My general thesis is that the velocity of production today in crypto is very difficult. If you look at Facebook and Web2, when Zuckerberg was in Harvard's dorm, he was able to do that in like 2 months, or like a month. Was able to do that without minimal startup costs. That same kind of Facebook like app would be very difficult to do in today's environment because you have to spend thousands of dollars in auditing fees, spend hundreds of thousands of dollars auditing the code. It takes a forever process. You deploy to mainnet, 2 weeks later it gets hacked. That's what happened with Stars Arena. And I think that's something we're trying to increase the velocity of production, where developers can have the flexibility to put an app on mainnet, not really worry about it getting hacked, and really scale their enterprise and not worry about security and more focus on distribution. So I think that's a key value prop that kind of goes under the radar. Security is really important to get any consumer app on chain. If you have a consumer app on chain and then it gets hacked 2 weeks later, you lost all your consumers. Whereas in Web2, that's not really possible. If it gets hacked, you lost like 3 images and maybe like a funny text.
And some personal data that nobody cares about, fortunately.
Yep.
Yeah, fully agree. Well, so here's to hoping you guys, get traction with these kinds of projects that really showcase what the Movement Network brings to the table. So this was a tremendously cool conversation. Thanks for coming on, Rushi. It was great to jam.